Everyone, this is ELEC 327, Lab 1, Part 2, the bonus. In the bonus, we're supposed to flash a message on an LED as fast as possible. As before, if you watched the previous video, we're going to be flashing SOS, and this time only SOS. And to make it go as fast as possible, I've decreased the unit of time, 1 unit of time for a delay or for showing a message to be 10 clock cycles. If you go below 10 clock cycles, you can hardly distinguish between a dot and a dash. And in this case, we're going to redefine a dash from being 3 times the length of a dot to actually 2 times the length of a dot, as specified by the guidelines. Okay. Additionally, I've also increased the clock frequency to 60 megahertz. That way, any type of overhead that may result from the code will be minimized. The impact of it will be minimized. So and if we go to the board here, the setup is the exact same. We still have the 300 ohm resistor to reduce current and voltage across the LED to avoid any type of unstable system. Okay, so let's run this. Okay, so we run this, and you can see it looks like it's on the whole time because the blinking happens faster than, well, it's faster than what I can see. So using banana clips, as you see here, I've connected this setup to an oscilloscope where we will analyze the waveform. Okay, so as you can see, you see shorter peaks, which corresponds to dots, and longer peaks, which correspond to dashes. If you can see here, it's actually a line right here. 1 dot is approximately one little section, and if we just position this again right around here, we can see a dash is around 2 of these 2 little sections. So that means a dash is pretty much twice the length of a dot. Okay, and we look at the time division. I set this to right here. See that it's set to, oh, that's very hard to see. It's not focusing. Okay, set to 5 microseconds. That means each one of these little sections is 1 microsecond long. So that means that means 1 dot flashes for about 1 microsecond. So if it was in a continuous on-off state, 1 unit of time on-off state, then the period of the signal would be around 1 megahertz essentially, because 10 to the negative 6, and if you take the inverse of that, that's about 1 megahertz. Okay, so yes, that concludes this demonstration. Thanks for watching, and I'll see you next time.